everyone, welcome back to another video. Today I'm going to show you the synthesis of rhodizonic acid and potassium rhodizonate. Now, rhodizonic acid is an organic compound and it is a sort of derivative of inositol, and kinda not really. Rhodizonic acid is formed from the oxidation of inositol, right there, or hexahydroxycyclohexane with nitric acid. Here I'm just using 70% nitric acid. You could use higher. I doubt if you could use lower concentration, but you just have to adjust the amount. And we'll also need some potassium hydroxide to turn the rhodizonic acid into a potassium salt, which is insoluble in water, well, pretty much. It is slightly soluble, but that's just how we're going to isolate it in the end. So you will need gloves for this, as we are dealing with nitric acid, as well as very, very good ventilation. I mean, mine's not super good, but I mean, it's a window fan, but it's the best I got for right now. Anyway, either do this outside, which I'm not because it's fucking freezing out there, and you would probably mess with the reaction. But yeah. So you're going to need really good ventilation because there's going to be a buttload of nitrogen dioxide that's going to be formed, and you're also going to need gloves and eye protection if you really feel that's necessary. So you might be asking, why are we making rhodizonates or rhodizonic acid? That's because they're very nicely colored, usually in the red range. Rhodizonic acid itself is completely colorless. It's a white solid. Actually, I have a little bit in a dram vial. Let me go grab that. So here's rhodizonic acid. I know it's not focused. Actually, let me fix that. There we go. It's a white solid, completely colorless, kind of opaque, and really nothing too exciting about it. But yeah, this is rhodizonic acid, and here is potassium rhodizonate. Quite a big difference there. It's almost like a dark maroon, like a very dark brown red, and yeah, it's just the potassium salt of this rhodizonic acid, and you can see it's such a big color change. It works sort of similar to how violuric acid works, if you've ever seen that, but it's a completely colorless acid, but its salts are extremely vibrantly colored. So yeah, with that being said, let's get on to the synthesis. Okay, so the amounts you will need of each are 10 grams of inositol, 25 milliliters of 70% concentrated nitric acid, and 40 grams of potassium hydroxide. Now, the way you're going to add this is you're going to get your inositol, your 10 grams of inositol, on a stirring plate / stir hot plate or whatever, and you're going to add 25 milliliters of the concentrated nitric acid to this. No reaction should occur unless your nitric acid is hot already. But then we're going to have to heat the mixture of inositol and nitric acid to form the rhodizonic acid. And that will generate a very large amount of nitrogen dioxide, so a good ventilation system is practically required if you don't want to die. Actually, I recommend the use of a humidifier of some sort. It will react, it will generate water to So with all that being said, let me go ahead and measure out 25 milliliters of the nitric acid. Okay. Now, I already have a stir bar in the beaker with the inositol. There we go. And that's going to be used to stir the mixture. What I'm going to do next is, basically this whole synthesis is following Nerdrage's preparation of rhodizonic acid and potassium rhodizonate. It's the same ratios, the same process, but it works really well, and I thought I might as well give a different sort of perspective on it. And do a little more testing with rhodizonates themselves. So, yeah, let me go fill this up with cool water. It's going to be used as sort of a crude condenser. I guess you could use a condenser, but you'd need a gas outlet for the nitrogen dioxide, so this really kind of works best. Okay, first I'm going to turn my ventilation on low. And then I'm going to add the nitric acid to the inositol. turn on stirring. Then what I'm going to do is put the flask on top of the beaker, and I'm going to turn the lip, or sort of this part of the beaker, towards my ventilation over there. That's where pretty much all the nitrogen dioxide is going to come out. And I'm also going to remove this, I have this metal piece on the back of my hot plate. I'm going to have to remove that as well, because I don't want it to rust, because this will probably destroy it. With the amount of nitrogen dioxide that's going to come off, it's not going to be good for it. So let me go ahead and remove that. Okay, going to turn on stirring here. And as this heats up, all the inositol pretty much will dissolve, leaving us with a practically clear solution. Oh my fuck, there's a hair in there or something. God damn it, that's going to annoy me. I got to remove that. Hang on. Get out of there, you God. Alright, well, that's all done. So, let me go ahead and turn on the heating. And you're going to want to heat this at a gentle boil, pretty much, and keep heating it, changing out the water in the condenser with cold water every so often, because it will, get hot enough to boil with all the steam and shit coming off. So, yeah. It's going to take a few hours for this reaction to complete. You'll know it's complete when pretty much all of the nitrogen dioxide evolution ceases. Then you can go ahead and, take it off heat, and I'll just come back when it's been a few hours. If you heat up the mixture too much, you might boil off some of the nitric acid. That will lower your yield a fair amount. And it also will mean that you will have an impurity of inositol, or derivatives of the reaction. So basically what I just did is added a few milliliters more of nitric acid, about, I'd say, as much as I lost. So about 2 pipettes full. It's not a huge pipette, but probably about up to here. And you can see the nitrogen dioxide evolution started again, which means there probably is a reaction going on. So I will leave this for probably another hour to react, changing the flask water out a few times, probably about 2 or 3 times in that time span. And then I will go ahead and we'll continue on, basically. Okay, it's been about an hour and a half, almost 2 hours, and we're about done, so I'm going to go ahead and turn off the heat, but I'm going to keep it stirring. Now I'm going to let this cool down to near room temperature, and then we can continue on with the synthesis. Actually, there's one cool thing we can do right now. Let me show you that. Here I have the reaction solution in a beaker, or the same beaker that was used for the reaction. And what I'm going to do here is take a little bit of the reaction solution up in a pipette, and then put it on a very, very cold watch glass. This watch glass has been in the freezer for about 2 hours. Let me get a little bit closer, and you should be able to see that pretty much everything has crystallized, and that is the rhodizonic acid, because basically what we have in the beaker is a super concentrated solution of, almost completely actually, of rhodizonic acid with a little tiny bit of nitric acid and maybe some water. And so when I put it on a cool surface such as this watch glass, it's almost certain that it's gonna crystallize out or precipitate or whatever. So yeah, that's pretty cool. There are basically two ways you can go from here. You can continue on and do the synthesis of potassium rhodizonate, or you can let this whole thing cool, get the solid rhodizonic acid, and wash it, basically put it in some, or mix it with some ethanol. That will precipitate out the hydrate of the rhodizonic acid, and you can isolate it from there. But since we're trying to, get different rhodizonates, we're just going to continue on. So what you're going to need here is some distilled water. Actually, let me go back to the hot plate. What I'm going to do now is just turn on stirring and adjust the total volume up to about 100 milliliters using distilled water. Perfect, and now we've made a solution of rhodizonic acid. Now we can go ahead and add about 50 milliliters or so of glacial acetic acid. This will serve the purpose of acidifying the solution because rhodizonic acid is more stable at lower pH. Here's the acetic acid. Great. From here, we have to cool it in an ice bath, and I really don't have a ton of ice on hand, so I'm just going to go outside and grab a lot of snow, I guess. Now what I'm going to do is weigh out the 40 grams of potassium hydroxide. Here I bought, this is a fresh container of potassium hydroxide I bought off eBay. Yeah, so I'm just going to weigh out 40 grams of this stuff, and then add it to the cold reaction solution. Okay, so that's about 40 grams. I'm going to go ahead and add this very, very slowly to the cold solution. Yes, you've got to be really careful with adding this because it's a very, very exothermic reaction, and the sound it makes is absolutely horrifying. It almost sounds like it really wants to kill you. So, I mean, I'll let you listen for yourself in here in just a second. Ugh. God. No, please don't hurt me. Yeah. Shit, man. Yeah, as you can see, we are starting to get a nice color change. As the potassium rhodizonate is formed, it will slowly turn a darker and darker red color. And then we will get a precipitate eventually towards the end of the addition. Do not add it too quickly, otherwise this will boil over. You may be able to start to see a red precipitate forming. This is the potassium rhodizonate. Let me actually get a little bit closer for you. There we go, much better. Here it is, exactly 24 hours later. What I'm going to do now is filter this and then do one wash with a little bit of isopropanol. Even a very, very small amount of rhodizonate can make quite the obvious color change. Next, I'm going to dissolve some potassium rhodizonate, as you can see I have in this vial here, in some distilled water. Then I am going to add this to some solutions of heavy metal salts. These include lead 2, praseodymium 3, cadmium 2, barium 2, iron 2, iron 3, and uranium 6, and we will see what kind of color changes take place. Each of the beakers that contain the metal salts contain 25 milliliters of distilled water, except for the uranium one. That contains about 15 milliliters, just because it's, I don't really have that much uranium salts. And a small amount, about the half of this spatula full of each of the metal salts was added, and a solution was made, again 25 milliliters. And what I'm going to do now is just add this rhodizonate solution, which you saw me just make, to these, and we'll see the color change. What I will also do is make sort of a control solution where I'm just going to have 25 milliliters of distilled water with nothing else dissolved in it, and then add some of the rhodizonate solution just to, see what it would look like if no reaction took place. guys, I really hope you enjoyed this video. It's really fun and interesting to make. You can like if you want to, subscribe if you want to, and thank you very much for watching. I'll see you all next time. Special thank you to my Patreon supporters, who help me make videos just like this. I wouldn't be able to do it without you guys. Thank you.